Okay, so we discussed the option pricing in the last lecture. So we started this binomial option pricing model. So first let me review this model. Remember what the question is about. So we basically have a stock. Its today's value is 100. And tomorrow it could have a price of 120 or 90. And then we have written a call option on this stock. And this call option has an exercise price of 100, expiration 1 year. And we assume the interest rate is 10%. And our question is, what is this call's price, right? So it's about the valuation of this call option. Then we use the two approaches to price this call. Both of these two approaches involve constructing portfolios. The first is a replication portfolio. The second is a hedging portfolio. In the replication portfolio, we use a bond and a stock, right? So it's a portfolio of bond and stock. And in this case, you can see that in this replication case, what we wanted to do is we want to make sure this replication portfolio's payoffs are the same as the payoffs of this call. And then by the law of one price, if this replication portfolio has the same payoffs as the call, then the present value of this call should be the same as the present value of this portfolio. So we could basically use the price of the stock and our investment in the bond to price this call option. We have a general formula, right? So basically, if the possible stock prices have only two values, right? So go up or down, and then the call price can be given by this formula, where this S is the stock price, delta is given by this formula, and B is given by this formula. And we also learned that this delta is essentially hedge ratio. And the second approach is about constructing a hedging portfolio. Since it's a hedging, what happened? Oops, sorry. Because it's a hedging portfolio, so you want to make sure that no matter what happens, this hedging portfolio will give you the same return. So you can see that what we will do is we will hold our long position in the stock, and then we will write 3 calls. And in the end, you could find out if you do this, 1 stock and 3 calls, then your portfolio's value will always be 90, right? So it's a fixed, riskless future cash flow, $90. And because this $90 is riskless, that is, no matter what happens, it's always $90. So you could basically discount this $90 using the risk-free rate, the 10% risk-free rate, right? And because we know that this portfolio of one stock and the 3 call options, they have the future value of $90. So the present value has to be the same as the discounted value of $90. So this gives us the solution. So the call price is solved by this equation, which is 6.06. And a very important concept in this hedging approach is about hedge ratio. In this example, to put it simply, hedge ratio is just the number of shares to the number of call options, right? So for example, in this, what happened? For example, in this hedging portfolio, we have 1 call with a short position of 3, we have 1 stock with a short position of 3 calls. So in this case, you can see that the hedge ratio is 1/3. And we could also learn that the hedge ratio equals delta, right? And delta is defined by the change in core values divided by the change in stock values, right? So this is actually a pretty important formula because it gives you the value of hedge ratio, and in the near future you will see that hedge ratio is a very important number in determining how you should hedge your portfolio. Now, let's think about this. Why should you use one share of stock with 3 call options to hedge against the risk? So let's see the definition of the hedge ratio. So hedge ratio is defined by the change in core value divided by the change in the stock price. So here P represents stock price, C represents the value of call options. And this one equals 1/3. So what does this mean? Well, it basically means that if stock price increases by 1, then option price will increases by 1/3, right? Now, you want to hedge against this risk. What can you do to construct a hedging portfolio? Well, you know that if stock price increases by 1, call option price increases by 1/3. So this basically means if you pair one stock, right? And if you pair this one stock with a short sale of 3 calls, then you can see that this price change will just offset with each other, right? Because you can see that if you have one stock, right? So the $1 price in the stock will give you $1, right? And then you have 3 calls, and you're actually short selling 3 calls. So 3 times 1/3, again, it's just 1. And because you're doing a short sell, so this time the call price will decrease by -1, right? So this +1 and -1 will just offset with each other. So you will have a hedging portfolio, which gives you this constant $90 payoff. Okay, so now let's continue to discuss this binomial model. So let's do a exercise, which is a more complicated exercise with 3 periods. If you recall what we have learned in the last class, you can see that our model is actually quite simple. The model has only 2 periods, right? So today, tomorrow, or to be more specific, this is at the beginning of the year, this is at the end of the year. So now let's say we wanted to get a finer model, right? What we're gonna do is so this is basically 1 year. And we will separate this 1 year into 2 sections. So the first section is this 6-month period and 6-month period. And let's say during this two periods, what you can see here is the stock price will actually work like this. So at the beginning of the year, 100. And then after 6 months, it could have 2 values. And then after this, another 6 months, it will have another 2 values, right? So you can see that this is a more complicated model. And now our question is, what is this call price, right? Again, we have the same call, right? So this call has 1 year expiration, and its exercise price is 110, and we again assume the annual interest rate is 5%. So what's the idea to solve this model? Again, we have 2 ways of solving this model. The first way is about this replication approach, and the second way is about the hedging approach. So let's first start with the replication approach. The idea to solve this 3-period model is you want to go from the last period, right? So let's say we will just focus on this part. Right? This is nice. Why this is nice? Because you can see that this is really the same as the model or the problem we just discussed, right? This is just a two-period model, and we know how to solve this. In the replication approach, we know that C equals S delta plus B. And what is delta's formula? Okay, to be honest, I can't memorize this. So let me see. Let me find out the delta here. So I'm looking at my computer and I'll copy this formula. So delta is CU minus CD divided by US0 minus DS0. I know the notation here looks actually quite confusing, but what is CU? It's really the cause payoff if stock price increases. And what is US0? It's really the price of the stock if its price increases. So here you can see that if the stock price increases, it would be 1 to 1. And if this stock price decreases, it would be 104.50. And now what is CU? Well, we know the exercise price is actually 110, right? So the CU is 11, right? It's essentially 1 to 1 minus the exercise price. What is CD? CD is the call options payoff if the stock price drops. And we know that if the stock price is 104.5, then the option holder will not exercise this call option. So the payoff is just 0. Right? So this gives us the value of delta, which is 2/3. Right? Now what about a B? Well, B equals CD minus DS0 delta 1 plus RF. Now, CD, well, we know what is CD here. It's just 0. DS0 is just this lower price, 1/4.50. Delta, we just solved. It's 2/3. What is RF? Well, if you look at this picture, you can see that this period, it's a 6-month period. So you should not use the annual rate. You should use the 6-month rate. So let's just assume a annual percent rate. So we will use 5%, right? So 12-month interest rate is 10%. So 6-month interest rate is 5%. And this gives us a number of minus 66.35. So now we have all these numbers we have, right? So C equals S. What is S? S is 110 times delta 2/3 minus 66.35. So this gives us 6.98. So it's actually pretty simple. It's really, I mean, it looks complicated, but once you decompose this process into several different options, you can see that it's really just a little more complicated compared with the previous example, right? So we know that the option price here is 6.98, right? Okay, great. So now let's see what is the option price here. Right? So in this case, we will focus on this lower half. Right? So we will focus on this. Well, in this case, the option price is actually pretty easy to solve. So what you can see here is, in this case, you know that your call option has an exercise of 110. So for both of these two prices, your payoff from the option is always 0. right? That is, you will not exercise your call option in either case. So what you can see here is your option value will be just 0, right? And next, we want to find this guy. What is the C here? Well, we will focus on this part, right? So we will do the same thing. Delta equals CU minus CD and US0 minus DS0. And then you can see that we have two different stock values, 110 minus 95, and when the stock price is 110, the option value would be 6.98, and when the stock price is 95, then the option payoff would be just 0, right? So this tells us the delta would be 0.0465, right? And then we could continue to use this formula on B. So CD would be 0, and oh, sorry, it's not 0, because we're looking at this guy. Oh yeah, it is 0, because we're looking at this guy here. So 0 minus the down price, which is 95. Delta is 0.465, 1 minus 5%. So this gives you minus 42, minus 42.07. And now what you would do is you would find out the call price, right? So S delta plus B, which is 100 times times 0.465 minus 42.07, which gives you 4.43, right? So that's how you use this replication approach to price this more complicated call option. Now let's think about the second approach, right? So the second approach is about using this hedging portfolio, right? So if you recall, when we were talking about the hedging portfolio, we want to find out the first step is the hedge ratio, right? So what's the formula on hedge ratio? Well, we know that hedge ratio has the same formula as delta, right? So it's again CU minus CD, US0 minus DS0. So again, we would start from this part. I will just directly give you the answer here. So we have, we basically have done this calculation. So it's 2/3. So this is the hedging ratio. And how do you exactly do the hedging here if you know the hedging ratio? Well, you note that hedge ratio is defined by the change in call value, right? So this is the change in call value, right? And this is the change in the stock price value. That is, hedge ratio is the change in call value divided by the change in stock value. This basically means if you want to hedge, then you should pair, or for every 2 stocks, right, you should short 3 calls, right? Again, basically, the number 2 in this hedge ratio represents the variation in the call value, and 3 represents the variation in the stock value. This basically means the variation in call value is smaller compared with the variation in the equity value. So this implies that for each 1 stock, you will need more than 1 call option to hedge against the risk. So that's why for 2 stocks, you will need more than 2 calls. That is, you will need 3 calls, right? So basically, the numerator 2 here represents the number of stocks. And then the denominator 3 here represents the number of calls, right? Okay, so let's see. If you pair 2 stocks with a short position of 3 call option, what is your portfolio's payoff? Now let's see this. If stock price equals 10450, right? Now your portfolio's value would be, remember you have 2 stocks, so it's stock price times 2, and you also have a short position of 3 calls. However, in this case, you can see that the call buyer, the call holder will not exercise the call because the stock price is actually lower than the exercise price. So the call is out of the money. So basically the payoff from the short position of 3 calls would be 0. So you can see that the total value or the total payoff from your portfolio at the end of the time would be 209, right? You can verify this is indeed a hedging portfolio by looking at the portfolio value if stock price turns out to be 1 to 1. In this case, again, you have 2 stocks, so this will give you this value. And you also have 3 calls. For each call, the call holder will exercise the call because now the call is in the money because the stock price is higher than the exercise price. So for each call, as a call writer or as a call option seller, you will lose 1 to 1 minus 110, right? So this will again gives you the same total portfolio value, which is 209. So this shows you that no matter whether the stock price increases or decreases, your stock portfolio value would be always the same, right? So this basically tells us 2 times 100 minus 3C equals 209 divided by 1 plus 5%, right? Again, the right hand side is the discounted value of this portfolio's payoff, right? And then the left hand side is the present value of this portfolio. Of course, these two values should be the same. So this solves C equals 6.98. Right? So again, we have got the same number. That is, you will have 6.98. And then you will see that it's again 0 here. Now, we want to go back to find out this guy, right? Again, we will construct a hedging portfolio. So C equals the difference in the call value divided by the difference in the stock. So this gives us a hedging ratio or delta, which is 0.465. So what does this mean? This means you will, so for 0.65 shares of stock, you will short sell 1 call, right? So how do we find out the price of the call? So let's again examine the portfolio's value, right? So let's say if stock price is 95. What is your portfolio's value? Well, you have this number of stocks times stock price. What is the payoff from the call? Well, obviously, in this case, the call will just expire worthlessly because it's out of money, right? So it's just zero. And in this case, your portfolio's value would be $44.175. So again, we could now price our call because we have this amount of stock and its present value is 100. And we have a short position of one call. And then this has to be equal to the discounted value of the future payoff. So this solves 4.43. Obviously, the hedging approach should generate the same answer as the replication approach. Okay. Oops, what happened? Okay, so now so basically you can see that you have the answers on this lecture note. So if you did not fully understand what I have just done, obviously you could read this lecture note and see these different steps, right? See how both the replication approach and the hedging approach work. Now, you might wonder something as follows. First, you might think this approach seems not very realistic, right? If you look at our first approach, we basically assume after 1 year, a stock would only have two possible values. In reality, this is not realistic, right? You can imagine that after 1 year, the possible values for Apple stock should be infinite, right? And you can see that even if you expand this model, if you use a 3-period model, then in the end, you can only represent 3 values, right? It's still very small, right? So how do you generalize this model? Well, you might have guessed it. What you need to do is you have to expand this process. Right? So what you're gonna do is you will use this finer method to expand this model, right? So if you continue to, if you continue this process, you can see that in the end, you will have more and more values, right? So you can imagine in today's world, if you know how to write programs, right, you could obviously use some programming language to automate this process. So in the end, you can actually very accurately approximate the possible values of your portfolio, right? So you can see that using computer, if you expand this process, then you can imagine that you can get a fairly accurate calculation of call price or put price, right? And why this is called binomial pricing model? The reason is because as you expand this process, as you have more and more values, the possibility of these values are given by a binomial distribution. And if you want to ask me why, if you want to ask me what is a binomial distribution, then I would refer you to your statistics textbook. And if you're interested, you could see why you will have a binomial distribution here. I will not talk too much about the technical details here, but it's actually quite interesting. Okay, obviously you can see that these 2 pages are not required. So I am talking about this because, well, in case you're curious, right? why this is called binomial model, and how could you make this very simple model more realistic. Okay, so now let's talk about the second evaluation method, which is likely to be the most widely used valuation method. So this Black-Scholes model. If you have taken corporate finance 2, it's possible you have learned Black-Scholes model because in that class, sometimes if I have time, I would actually talk about the Black-Scholes model. So now let's start with a simple case. So now let's consider a call option without dividend, right? So we wanted to price this call option. Now Black-Scholes formula will directly gives you a result. So this model tells you the call option can be calculated like this. Now let me explain what are these notations. So C0, well, C0 is just the call price, right? That's what you want to get using this formula. What is S0? S0 is the current stock price, right? And let's first skip ND1. What is X? Well, it's just this exercise price or strike price, right? What is E? E is the mathematical constant, or you could say it's the base of the natural log function. And E approximately equals 2.72. R here is the risk-free interest rate. T here is the time to expiration. It's measured in years, right? So if it's 1 year, you should write T equals 1. If 2 years, you should write T equals 2. So if 6 months, then you should write T equals 0.5, right? Now let's talk about ND1 and ND2. First, what is D1? Well, D1 is given by this formula, right? So you can see that it's actually quite complicated. What is this ln? Ln is the natural log function. Again, S0 is the current stock price. X is the strike price. R is the risk-free rate. And sigma, what is sigma? Sigma is the volatility or annualized volatility of the stock's return. And T, again, is the time to expiration. And D2 equals D1 minus sigma times the square root of T. Now, what is N? Well, N is the probability that a normally distributed variable is smaller than ND, right? So that's the definition of ND here. Clearly, you need some basic understanding in statistics or probability theory to understand these things. So if you have difficulty to figure out what is the normally distributed variable, then you should consult your textbook, right? You should go back, open your book, and look at related chapters. Okay, so if you think about the probability density, if you think about the probability density function of a standard normal distributed variable, right, it looks like this. It's a very nice bell shape, right? And let's say if you want to find out n.5, how could you represent this probability on this picture? So this is a probability density function. Well, you will look at this 0.5 value, and then the probability is given by the area under this probability density function until this 0.5 value, right? So the area of this green shaded, the area of this green shaded area gives you the probability, right? Okay. Now you might wonder how the Black-Scholes formula is related to the binomial model we just talked about, right? So remember, in the replication approach, right? Let's think about the replication approach. In that approach, we know that call option equals stock price times delta plus B, right? Now let's look at the Black-Scholes model here. So if you copy the Black-Scholes model, then it's S0 N D1 minus X ERT N D2. So now you can see their relationship, right? So they essentially have the very similar structure, right? So you can see that delta and ND1, they're the same thing. And B and this guy, let me use a different color. Oops. And the B and this guy, they're the same, right? So that's how these two models are related. It basically says that if you're using Black-Scholes model, you could directly compute delta by ND1, right? So ND1 basically gives you the delta. And we also know that delta and hedge ratio are the same thing. So you can see that ND1 gives you delta, which also gives you the hedge ratio. So you can see that Black-Scholes model is actually very convenient because it is a nice formula which directly lets you compute the hedge ratio. Okay, let's see an example here. So let's say we have a call option with the following data. Its current stock price is 100, and its exercise price is 95, 10% risk-free rate, and 0.25 years. That is, it has a time to expiration of 3 months. Again, in this Black-Scholes formula, time is always measured in years, so you have to do this conversion here, right? And then we assume the stock return has an annual volatility of 50%. Now, how do you price this call option? Well, as I said, pretty easy, right? Directly apply the formula here. So let's start with D1. Right? So D1 equals the log of S0 divided by X plus R sigma squared 2 and T and sigma squared T. Obviously, you can see that you have every number you need, right? So you could just plug in numbers here, and this will give you 0.43. Of course, if you're at home reading this lecture note, and you could have time to exactly plug in these numbers and check, you will indeed get this 0.43. And then D2 equals D1 minus sigma times square T. So again, plugging numbers, right? So this gives you 0.18. And now finally, the call price equals S0 times ND1 minus XERT ND2. So S0 is basically 100, right? And ND1 is really N043. Now what is X? It's 95, right? So E, what is R? It's 0.1. And T is 0.25. And ND2 is N.18. So clearly you have every number you need to find out the call option price. What you need to do is to find out this N043 and N018. So one way to get this is you could use the Excel function So norm SD IST. So it's basically normal distribution. So here you can find out this M043 equals this and N018 equals this. So plugging numbers back into this formula, you can find out the call option price is 13.70. So you can see that why Black-Scholes model is widely used and preferred. It's really because it's really a simple process, right? As long as you understand what each notation represents, you could correctly plug in numbers, then you get your answer. Okay. Another caveat I forgot to mention is, if you look at this lecture note, it says the Black-Scholes formula for a call option without dividend. We know that at least call option has two types, right? American calls and European calls. So what exactly is this call option? Well, the answer is here, this formula can be applied to both American calls and European calls as long as there are no dividend. Why? The reason is, well, we actually talk about this. The reason is because if a American call option does not pay dividend, then you should never exercise this call option early. Which means the early exercise does not have value in American option. So this implies American call should have the same payoff as a European call. So they should have the same formula, right? So that's why you could use the formula to price both American call and the European call without dividend. Okay, a very important application of Black-Scholes formula is about implied volatility. If you trade, if you have an investment account, it's very likely you have heard about implied volatility. First, what is the implied volatility? Well, if you look at this formula, what you can see here is if you have call option price, right? I mean, in the market, when you're actually trading call options, you can just take call option as given, right? Because the market will tell you what is the call option price, right? So given the call option price, given the stock price and other related data, what is the volatility? That is, I consider volatility as an unknown in this pricing formula, and I consider the call price as a known parameter. So what is the volatility implied by this option price, right? Or you could see this here. So in this example, we have these 5 data points, and we can find out the call price, right? So this basically means that if I don't know this, this basically implies that if I don't know the volatility, and if you tell me the call price is 13.70, then given these 4 data and this additional call price, I can solve sigma, right? I can solve sigma equals 50%. So in this case, given call price and I solve sigma, this solved sigma is called implied volatility because it is the volatility of the stock implied by the option price according to the Black-Scholes formula, right? So in the actual financial market, there is this very famous index which is called VIX Index. So what is a VIX index? It's really a measure of the implied volatility of the US market. So how do you obtain this VIX index? I can't recall the details, but basically what you need to do is you need to solve volatilities from this SP 500 options, right? So if you look at those call option prices, you can back out their volatility, and this is your implied volatility. And this implied volatility, when you're using SP 500 options, then it is called VIX index. VIX index is a very important index. So it also has a name which is called fear index or fear gauge. Why it has such a name? The reason is because whenever market drops, VIX would increase. Generally, it's almost 80 or 90% of the time. So there is this negative correlation between VIX and market performance. So that's why it is called fear index, right? So it basically says if the market is in fear, if the market is in panic, it drops, then VIX will increase. Empirically, you can see this is indeed the case. So this is the data of the VIX index taken down from CBOE. Right? So CBOE is the short name for Chicago Board Options Exchange. Right? So what you can see here is normally the VIX can be as low as as low as 10, but when the market was in distress, the VIX can actually explode, right? You could see that in Gulf War, you have a VIX reading of 30. In the LTCM event, the VIX reached 45. So LTCM is the short name for long-term capital management. It was a very big asset management. It was a very big asset management firm at the end of the 1990s. So that firm was actually advised by two Nobel Prize winners, and they basically used some bond arbitrage strategies to make money. However, I think it's at the end of the 1998, there is this Russian debt crisis. And this event, I think, caused their portfolio, caused LTCM's portfolios exploded. So basically, they went bankruptcy, something like that. And it created a huge financial trouble in the market. And then, of course, 911, everyone knows it. This should be the Iraqi war, I think. Everybody knows it. Financial crisis, everybody knows it. US debt downgrade. So this is an event in 2011. At that time, I think a credit rating agency, I think it's either Moody's or Standard and Poor, they downgraded the US government debt from AAA rating to AA rating or maybe AA plus rating. But anyway, there is a downgrade in the US government bond. So this again created a shock in the market. If you look at the recent event, so if you look at VIX index in the recent event, you can see that during this COVID panic period, VIX reached 82, right? I think 82 is actually the highest in the whole history, right? So you can imagine that time the market was really in panic mode. Okay, great. Now let's talk about the Black-Scholes models with dividend. Remember when we first discussed the Black-Scholes model, we said it's good if the stock does not pay dividend. So you can use this formula to price a call option. However, you might wonder, what's the more realistic case, right? If the stock actually pays dividend, how could I price the call option? Well, it's actually pretty easy. Remember that the original formula when the stock does not pay dividend is given by this. And if the stock pays dividend, what you do is you just adjust this stock price. How do you make this adjustment? Well, you could use the stock price minus the present value of the dividend, right? So this will give you the valuation formula when this stock pays dividend. However, a caution here. This formula, that is the call option pricing formula with dividend, right, can be only applied to European calls. You cannot apply it to American calls. Well, because we learned about this in the last lecture note. We learned when there is dividend, it's possible if you have American calls, it's possible you will want to exercise this call option early. So this implies that when there is dividend, the option to exercise early has value for a American calls. This means American call should be more valuable compared with a European call when there is dividend, right? So, however, a lot of times you can actually use this formula as a approximation because even the American call option's value is higher than the European call option. Their value would be actually close. Now, what about a put, right? What about put option? First, we will not discuss the valuation formula for American put because we know that it's possible for American put you will want to exercise early, right? So we will just examine what is the valuation formula for a European put option. Well, this is actually pretty easy. What you can do here is we have learned about this put call parity, right? So when there is no dividend, according to put call parity, right? Put equals call. Okay, let me find a better place. Right? So when there is no dividend, we know that put equals call plus present value of the exercise price minus today's stock price. And we have learned the formula for the call here, right? We know that call equals S0 times ND1 plus PVX. Oh, sorry. So minus XERT times ND2 plus PVX minus S0. And you can see that we can combine these, right? So PVX is the present value of X, that is, it's XERT, and then you can find out this term and this term, they can be combined. And this term and this term, they can be combined, right? So essentially we will get, let me follow the lecture note. So essentially we will get XERT 1 minus ND2 minus S0 1 minus ND1, right? So basically, if you have the call option valuation formula for European calls, then using put-call parity, it's very easy for you to find out the valuation formula for European put option, right? And again, you can very easily find out the formula for European put option with dividend, right? What you can see here is if you look at this formula here, you can see that this formula also gives you delta. Because if you look at this this binomial approach, you can see that delta is essentially the number after the stock price, right? Again, delta is the number after the stock price. So in the put option case, it's still the same. So what is the number after the stock price? It's 1 minus ND1. Well, you should not forget this minus sign, right? So you can see that for a put option, right? For put option, its delta equals minus 1 minus ND1. That is ND1 minus 1, right? Basically, you can see that for put option, delta is negative, or the hedge ratio is negative. And for call option, you can see that the delta is always positive, because for put option, because for call option, delta equals ND1, and ND1 is a probability. We know that probability is always larger than 0, so delta is a positive number. Okay. Now, let's talk about hedging. First, well, we actually talk about this. We know that what is the definition of hedge ratio, right? We know that hedge ratio is defined by the change in option price, right, divided by the change in stock price. So that's why hedge ratio gives you the change in option price for a $1 increase in the stock price. The word increase is not the best word here. Maybe it's more accurate to use change. So the change in option price for a $1 change in the stock price. And we also know that hedge ratio equals delta, right? Oops. Oh boy, that's right. So it equals delta. And we have also learned in the Black-Scholes formula, right? If you have a call option, its delta equals ND1. That is the hedge ratio here. If you have a put option, its delta equals ND1 minus 1 equals the hedge ratio. Now let's see some examples. Try to understand how the hedging works. So let's say you're writing one call option on a stock. So you're a option seller, and you're selling calls. Why do you want to sell call? Well, because when you sell calls to a call option buyer, this buyer will give you money, right? So you want to earn that money. Now suppose the option delta, that is ND1, equals 0.6. How should you hedge? That is, how many stocks should you buy to hedge against your short position in call option? Well, this one is actually similar to the previous to the previous example, right? So let's maybe review the previous example. So in the binomial pricing approach, we discussed this hedging portfolio, right? So here we learned we can actually hedge one stock with a short position in 3 call options, right? So basically it tells you that if you have a short position in call, then you should take a long position in stock, right? Why that's the case? Well, think about this. If you're the call seller, now think about this. If you're the call seller, when you will have a loss? Well, it's when the stock price increases, right? Because when the stock price increases, the call option buyer will exercise the call, and you will have to sell the stock at a price lower than the market price to the option buyer. So how could you hedge against the risk? What you can do is, when you're writing calls, at the same time, you should purchase some stocks. In this case, even the stock price increases, you will just give your existing stocks to the option buyers, right? So you will not face this risk because of the appreciation in the stock price, right? So now let's see how could you use this hedge ratio to solve how many shares of stock should you hold to hedge against your risk as an option seller. Now let's see this option delta. So we know that the hedge ratio is 0.6. What does this exactly mean? It means if stock price increases by $1, then the call option price should increase by 0.6, right? Because by definition, the hedge ratio is the change in option price divided by the change in stock price, right? And we have a positive hedge ratio. This implies if stock price increases by 1, then option value should increases by 0.6, right? So this essentially tells you that you will this tells you for 0.6 shares of stock. So this basically tells you that for one call, you will buy 0.6 shares, right? So if you sell one call, you will buy 0.6 shares. You will verify this is actually true, right? Think about this. Let's say, if stock price increases by 1, now you have a short position of 1 call, and you have 0.6 shares. Then you can see that the value of your total position in the stock will increases by 0.6 by 1, right? Because you have only 0.6 shares. And you have a short position of 1 call option. And we know that call option price will increases by 0.6. And you have 1 call. But you are having a short position. So this position will generate a loss like this, right? So you can see that a positive gain of $0.6 will offset a loss of $0.6. So your portfolio is hedged. This is actually what happens when people are selling calls, we generally will buy some shares as the hedge. Okay. Now let's look at the second example, which is hedging with a put option. So let's say you have one share of stock and you're worried that possible negative news will come, so the stock price will actually drop, right? So you want to hedge against this risk, and we assume ND1 is 0.5 at the current stock price. How do you hedge against? Well, a general result about hedging this type of risk is you will want to buy put option as a portfolio insurance. Now let's see how this could help you. So first, let's say you will want to buy put options. And we know that if you have a put option, then the hedge ratio is ND1 minus 1, which is minus 0.5. So this means if stock, so this basically means if stock price decreases by 1, the put option will increases by 0.5, right? Remember that we have a negative sign here. So that's why if there is a decrease in stock price, you will have an increase in the put option value. So they should move in the opposite direction. Now, how do you exactly hedge? Well, it basically means for one stock, you will have two put. You can calculate if you have a portfolio like this, you're actually hedged against this downside risk. Why? Let's think about this. If stock price, right, let's say if stock price, oh geez, what happened? So if the stock price drops by $1, what is your loss in your stock position? Well, you will incur a $1 loss, right? However, you have a put position, right? We know that if stock price decreases, your put options value will increase. And we know that the hedge ratio is 0.5, which means stock price decreases by 1, put option value increases by 0.5. And now you have two puts. So the total increase in your put options position is 2 times 0.5, which is 1, right? So you can see that the loss in the stock position will be offset by the gain in the put position. So in the end, the portfolio's total value will stay the same if there is a decrease in your share price. So you can see that using a put option, you can insure against this stock downside risk. Okay, this might seem very straightforward and simple, but actually hedging is a dynamic process. Why it is a dynamic process? Here, dynamic process basically means you have to continuously monitor your position and rebalance your position and adjust the number of calls versus number of shares, number of puts versus number of shares. Why do you have to make an adjustment? Well, the reason is because delta changes, right? That is, as share price change, delta will change. If delta changes, the hedge ratio changes. This means you have to make an adjustment in your hedging portfolio, right? And what you can see here is if you look at the left-hand side, left-hand side tells you how the value of a call changes if stock price changes. So the slope of this curve gives you hedge ratio. Right? What you can see here is if it's a call, when the stock price is low, then hedge ratio is small, right? And when stock price is larger, hedge ratio becomes larger, right? So this basically means that for call, hedge ratio increases as stock price increases, right? Now, if you look at this right-hand side, you're looking at the value of put versus stock price. What you can see here is if stock price is low, then the slope of the curve is low, which means hedge ratio is small. And when the stock price becomes even lower, right? Let's say it approaches zero. Now the slope is higher, so hedge ratio becomes higher. So this basically means for put, hedge ratio increases as stock price decreases, right? So the gist here is hedge ratio changes if stock price changes, right? Okay, now let's see what kind of implication you can get from these two pictures. So first you can see that for call options, right, stock price increases, hedge ratio increases. Now remember we discussed this example of call option writer. It says that if you're a call option writer, you have to hedge against your risk by buying shares, right? You will have an equity position. And this basically means that if stock price increases, as a call option writer, you will have to buy more stocks for hedging if the hedge ratio increases. Right? And then what about the put option? Well, we have shown for put options, if stock price decreases, hedge ratio would increase. Right? This basically means that if you don't change the number of put options in your portfolio, if you want to continue to hedge your portfolio, you will have to sell some shares. Right? So this is called dynamic hedging or delta hedging. It's called dynamic hedging because as share price changes, you will dynamically rebalance your hedging portfolio. This is called delta hedging because the hedging is based on option delta. And this also has some interesting implications on market price. So if you look at the first, if you look at this result, it basically says that if stock price increases, right, for hedging purpose, option writers will buy more stocks. What's the implication here? It means that if price increases, these option writers will push the price even higher, right? If you look at the second case of the put option hedging, what you can see here is as stock price decreases, stockholders will need to sell stocks, right? This means if price decreases, then more selling will come. So stock price will decrease even more. So the implication here is like this. This hedging technique will increase market volatility. That is, If market declines, then hedgers will sell shares, so market will decline more. If market price increases, these hedgers will buy more stock, so this will push market price higher, right? So basically this means hedging increases both the upward movement and downward movement, right? Okay, that's for